We're just going to run through fractional indices. Like, what does an indice of a half mean? We've done indices like of whole numbers, like x to the 3, and negatives, like x to the 3 just means x times x times x. That's what that 3 means. X to the minus 2 means 1 over x to the 2. We know anything to the power of 0 is 1. But what does it actually mean when you have a fractional indice, like x to the power of a half? Now, if you have anything like as of x to the power of 1 over, and you have a number on the bottom, it's a fraction, it's actually the nth root of x. So, for example, if I have 8 and I had it to the power of third, that just means the cube root of 8. The cube root is the opposite to cubing. So it means what times what? So let's try 2. 2 2s are 4. Times 2 again will give you 8. So the cube root of 8 is actually 2. Because 2, if you multiply 2 by itself, and you did that 3 times, you would get 8. So the question is, why does that actually happen? I'll just show you the square root. Like if I had, let's say we have 4 to the power of a half, that means the square root of 4. Now we don't usually write that 2 out the front there. We usually just write it as the square root of 4. And the square root of 4 is what times what will give you 4. So 2 times 2 is 4. So the square root of 4 will just be 2. Okay, so what's happening now is I'm just going to show you why that works. So we'll start off and we'll do it for the square root. So the first thing that I want you to realise is that if I go and I did x, if I did x times x, that will equal x squared. Now, if I multiply two things together and it gets a square, like 3 times 3, that is 3 squared. Okay, so what I would like you to think about here now, that if I have like x squared and I make that equal 9, if I want to think about what does that actually mean, what x value would you multiply by itself to give 9? And it'll be 3, because 3 times 3 is 9. Now, see how this here is a square. So the opposite to squaring is square root. So instead of going 3 times 3 is 9, therefore the x value is equal to 3. What you could do is you could go the opposite to squaring is the square root. Because remember, it's an equation, and when I do opposites, to solve an equation to get rid of that square, you do what's opposite. So the square root of 9 is equal to 3. The same as if I had x squared equals 4. Then the square root of 4 will equal 2. So the opposite to a square, the opposite is a square root. Okay, so we're just going to look at a scenario. Let's look at if I had x to the half times x to the half. Okay, that would be a half plus a half, because remember you add the indices. A half plus a half is 1. So that means x to the half times x to the half will equal x to the 1, or just simply x. So that we did that just through adding the two indices of a half and a half just to get the 1. Okay, so when I multiply something by itself, then another way of actually writing that is to go x to the half and you write it squared. It's the same as if I had y times y, we'd write it as y squared. If I had 4 times 4, it could be 4 squared. So x to the half times x to the half is x to the half all squared. Now that equals x. So now if I just use that equation work, this is a pretty hard proof really, but use the equation work, the opposite to squaring will be square root. And see, that will be the square root. That little 2 goes there. So therefore, x to the half is the square root of x. And you could also develop the same thing for a third. See, x to the third times x to the third times x to the third will equal x to the third plus a third plus a third, which is x to the power of 1. So x to the third, because there's 3 of them, that will be x to the third cubed. That's going to equal x. So now if I want to remove that 3, what's the opposite to a power of 3? Well, the opposite to a power of 3 is a cubed root. The opposite to a square is a, so if you have something to the square, the opposite is a square root. If you have a cube, the opposite to a cube is a cube root. If you have a fourth, the opposite is a fourth root. So you can see in both of these there is a common rule here. So therefore you can just go x to the power of 1 on n will be the nth root of x to the n. Okay, and you could just apply that just by doing, if you write this and you write it as a root, it will be the square root of 5. If you have 3 to the quarter, that would be the fourth root of 3. So notice here that 4 ends up on the bottom. So the 4 here ends up on the bottom, the 2 here ends up out the front. So at the door, there's a way of remembering this, so I'm just going to run through. So this one here would be root 2, but the 1 on the floor, on the bottom of the fraction, will be at the front of the root. So that would be 5. So a way to remember this is at the door is on the floor. Okay, so see how these numbers here are at the door. See how they're at the door? And even the 2 that's not there, they end up on the floor or on the bottom of the fraction. That's just a nice little way of remembering it. And then the other thing is, what's on top stays on top. So do you notice these all have a power of 1? So that's why 1 ended up on top. In actual fact, if you had, let's say you have the cube root of x and you had to the 2, then that in index form, the 3 is at the floor. On the floor, the 3 is at the door, and the 2, this power of 2, what's on top stays on top. So that means that will be 2 will go there and 3 will go on the bottom, and that's what the root will look like in index form. So if you have the fifth root of 5 to the 4, 5 is the base, so that will just stay the same. And then you need to write a fractional indice. So you go, okay, so what's on top stays on top, so the 4's on top, and at the door will be at the floor, and that's what it looks like in index form. So you can write 2 to the 5 on 3 in root form. That's going one way. Or you could write the cube root of 5 to the 2 in index form. That's going back the other way. So as a general rule, if you want to go to index form, if you want to go to root form, and instead of root form, the words they sometimes use the word surd form. Okay, so going from the root form, so n x to the m, to the index form, sorry, this is n x to the m, I'll put it there. And then we're going to go to index form. So this is x m over n. So basically, when you do this one needs to be x to a power, and this one needs to be x with a root, okay? And what happens here is the number at the front is what will go on the bottom of your fraction, and the number on top of the power will stay on the power. What's on top stays on top. Okay, so let's just answer these two questions. Write that one in root form. So you go root 2. So the 5 is on the top, so that's not where it goes, sorry. The 5 is on the top, so what's on top stays on top. So 5 will stay on top, so that goes in there. And the 3 is at the floor, so the 3 needs to be at the door. When you do the next one, that one there, 5 is the number, 3 is the root, so it's down the bottom. At the door is on the floor, and the 2, this 2 here is at the top, because what's on top stays on top. So the 3 goes down the bottom, and the 2 goes to the top. What's on top stays on top, and also the other one's the root.